the extended chain rule. We're going to look at some notation for composite functions here, and this is f of g of x. In other words, you take f and you plug g of x in instead of x. And another way of writing that is f circle g of x, and a third way is just f circle g. And always this g is inside the function f. Okay. You should familiarize yourself with composite functions really before you begin working with the chain rule. Sometimes it's useful to combine the two notations, that is f of g of h could be f using this first notation with g of h using this second notation. It all means the same thing, however. And this notation, combining the two, is very useful for explaining the extended chain rule. Now we're not going to extend this on into infinity, we're just going to do 4, and once you see how it's done with 4, then it's done the same way with 5, 6, or any number. And so we've got the derivative of f1 of f2 of f3 of f4 with respect to x, and these are all functions of x. Well, here's how you do it. You take the derivative of f1 and you put the composite of f2, 3, and 4 in times the derivative of f2 with the composite of f3 and f4 in times the derivative of f3 with just f4, and then times the derivative of f4. And you can see there's a nice little pattern running here. The example we're going to do is only going to have 3 functions, but again you can see how this would be expanded. And the example we're going to do is the derivative of the sine of the cosine of negative 5x. Okay, so we see we have 3 functions in there. We've got negative 5x inside the cosine, and all of this is inside the sine, right? And so I'm going to list all 3 functions as f1, f2, and f3. And here's f1 prime, f2 prime, and f3 prime. And then, just as a helpful reminder, f2 of f3 is cosine of negative 5x. Now, we can use our formula. Our formula would say that the derivative of the sine of the cosine of negative 5x is the derivative of f1 of f2 of f3. And this would be f1 with the composite of f2 and f3 inside times f prime 2. Did I say f prime 1 there? F prime 1 of this composite, f prime 2 of f3, and then just f prime of 3. Just a shorter version of the 4 function rule that we had above. Now all I have to do is plug in the right thing. I have to have f prime here, cosine, and put this inside, right? Cosine of cosine negative 5x. Then I have to have f prime of 2, which is negative sine x with f3 stuck in, and then times f prime negative 5. And that's what I do right here. Here it is all written out. And notice how it goes. Here's f prime of 3. Here is f prime negative sine of f of 3. And here's f prime of 1 with f2 of f3 inside. And then we can make that look a little better using the commutative rule of multiplication. And the sign, of course, the negative sign times the negative 5 makes positive. And here's the answer in slightly better form right here.